So today we're going to be looking at balance. Balance in the human body is chiefly controlled by the vestibular system, which acts to measure and understand or interpret motion and movement around the body. It is comprised of three semicircular canals, with that being the superior, posterior, and horizontal. These are situated orthogonally to each other, or basically at right angles, and this allows the body to sense angular acceleration in the different planes due to their orientation. Basically, how this is done is that these canals are filled with endolymph, which is the same endolymph that we find in the cochlea, and it has a very high potassium concentration. But basically, it sloshes around based on where the head is moving, and therefore, we're able to detect movement based on being able to convert this sloshing mechanical movement into an electrical signal that the brain is able to process. And how exactly does it do this? Well, it's via the sensory components of the vestibular system, which are our ampulla, our utricle, and our sacculus, which detect angular acceleration, horizontal, lateral acceleration, and vertical acceleration, respectively. Exactly how the body is able to do this comes down to two main components of the sensory units, which is the capilla and the macula. These both feed into hair cells found very similarly in the cochlea, and basically they are mechanically gated stereocilia, which bend depending on the deflection of the fluid within our canals. The capilla is found in the ampullas, whilst the macula is found in our sacral and utricle. The capilla is bound to or attached to hair cells beneath it, and basically the deflection of the capilla due to movement of the endolymph within the semicircular canal causes deflection of the capilla, and in turn deflection of the hair cells moving either towards the kinocilium or away from the kinocilium. And if we look at the diagram to the right, we can see that if movement is towards the kinocilium, which is the largest stereocilia found on a hair cell, it causes these gated potassium channels to be basically pulled open, much like a swinging door which closes automatically on itself, but this time it pulls them open based on how much the capilla is deflected by the motion of the fluid or the endolymph. This then causes potassium to rush into the hair cells and causing a depolarization. This then converts into an electronic signal, creating a neuronal impulse, therefore allowing the brain to interpret the motion that is occurring, converting a mechanical input into an electrical signal. As you can see on our hair cells, it is much like a tiered system, and therefore we are able to create a force-dependent system, and therefore with greater forces or greater acceleration in certain direction, we get increased deflection of our hair cells, and therefore we get increased firing or depolarization of our hair cells, and thus increased input into the body for the body to register that increased acceleration. The macula work in a very similar way. However, they have an extra component on top of that known as the otoliths, which contain atonocytes or calcium carbonate crystals, and this forms a membrane above more hair cells which act to detect our vertical or lateral acceleration, respectively. An interesting case study to look at is benign proximal positional vertigo. As stated in its name, it is benign in nature, but causes quite severe nausea and vomiting for the patient due to the severe vertigo it creates. This is because the otoconia of the otolith membranes have dislodged and began circulating through the semicircular canals. This causes a change in the viscosity of the endolymph, and therefore a small movement which was registered as before will now cause a massive depolarization, which in conjunction with the sensory input provided by the eyes no longer match up to what is happening and therefore causes the spinning sensation people get in vertigo and therefore the nausea and vomiting symptoms that are as a result.